There we go. Okay, yay, we got it back. Let's see. Let's get our screen share going again. Okay, so the last thing we talked about was 132, 133, 2 through 36 evens. And now we are going to move on to page 136, proof and perpendicular lines. So here we're going to start with perpendicular lines. Move this along. Okay, and it says comparing types of proofs. There's more than one way to write a proof. The two-column proof below is from lesson 2.6. It can also be written as a paragraph proof or as a flow proof. A flow proof uses arrows to show the flow of logical argument. Each reason in a flow proof is written below the statement it justifies. Okay, so if we look at example 1, we can see that we have got a pair of intersecting lines. We can see that 5 and 6 are a linear pair, 6 and 7 are a linear pair, and we're trying to prove that angle 5 is congruent to angle 7. Okay, so method 1 is the two-column proof. So we can see where we have it listed out in our statements and our reasons. Okay, so we can make those correspond side to side. Our paragraph proof has it written all in one paragraph. Okay, and then we can look at the flow proof. And it says with our flow proof, we have our 2 bits of given information that are given at angle 5, angle 6 pair, angle 6 and angle 7 are a linear pair. So we have it to where that is the given. Then we can see the arrows show that 5 and 6 are supplementary. 6 and 7 are supplementary. Therefore, they both go and lead into the congruent supplements theorem, which is the part that we were trying to prove. Okay, so there are 3 proof methods that can be used. Okay, so this is just kind of exposing you to the flow proof. So one of the things that you can do is, if we look, to me, the flow proof can get a little hairy. It can get a little confusing, okay? For me personally, I like the statements and reasons. I like to be able to see everything in a linear fashion to where I go step to the step. As we can see on page 137, it flows. It goes from one thing to another based on the arrows, but to me that looks like a whole lot more work than dealing with just our statements and reasons. Okay, so we're going to look at it just to know that it exists, but as far as work and assessments and things like that, we're going to be sticking with the basic two-column proof. Okay, so we can see though at the top of 137 we have a few new theorems. So green box information means blue folder. All right, so theorem 3.1 says if 2 lines intersect to form a pair of congruent angles, then the lines are perpendicular. So if we have congruent angles, meaning that they are equal to each other, and those congruent angles were formed by the lines intersecting, then I know that they're 90-degree angles, because the only type of intersecting angle that can be congruent would be 90 degrees, okay? Theorem 3.2, if 2 sides of 2 adjacent acute angles are perpendicular, then the angles are complementary. What does complementary mean? The sum is 90 degrees. Good. So when we look at our figure, we can see that our larger angle, we can see that, okay, we can see that our larger angle right here, they've told us it's a 90-degree angle. But then I have a ray coming out, okay? And so it makes two acute angles, because remember, acute angles less than 90 degrees. So if I have an angle that is turning these into two smaller angles, then I know they're both going to be acute. They are adjacent because they share a common side. So remember, adjacent angles have a common side. Add them together, they equal 90 degrees. Theorem 3.3, if two lines are perpendicular, then they intersect to form 4 right angles. So I can see I've got 4 different right angles formed based on perpendicular lines, okay? So I know that these would be a linear pair, and that would equal 180. So if each one is 90 degrees, what is our total all the way around? 360, good. All righty, so we can see this proof of Theorem 3.1. It says write a proof of Theorem 3.1. So the given angle 1 is congruent to angle 2. Angle 1 and angle 2 are a linear pair. Prove that G is perpendicular to H. Then the plan for the proof says to use the measure of angle 1 plus the measure of angle 2 equal 180 degrees, and the measure of angle 1 equals the measure of angle 2 to show that the measure of angle 1 is 90 degrees. So the first thing they did is start with the given information. That angle 1 and angle 2 are a linear pair. That's our given. So notice here in the box of the flow proof, you have basically what we use in the 2-column proof. You've got your statement, and then your reason is right under it. So the statement is angle 1 and angle 2 are a linear pair, and that's from my next step down. Angle 1 and angle 2 are supplementary. The reason for that is the linear pair postulate, okay? So we know that these two are supplementary. We've already stated that they're a linear pair. They're supplementary because of the linear pair postulate. Then it goes down, angle 1 and angle 2 equal 180 degrees, and that's the definition of supplementary angles, okay? So as we kind of follow this through, they're a linear pair, which means that they're supplementary. If they're supplementary, I can add them together to equal 180 degrees. Okay, so then we can see it kind of veers off here. And if I can get it to shrink down. We can see that I can put in the measure of angle 1 plus the measure of angle 1. We're substituting here. Okay, so we're using the substitution pair because we've already said that over here from our other given information is that angle 1 and angle 2 are congruent. Okay, so basically knowing that angle 1 and angle 2 from our given are congruent, that their angles measure using this information and the definition of supplementary, I'm able to use both of these things to show that I can substitute that measure of angle 1. Then because I have the measure of angle 1 written twice, this is where I use that reverse distributive property. And I have 2 times the measure of angle 1 equals 180. So the reason was because of the distributive property. Anytime you see something go from 2 of the same thing to where it's 2 times 1 in parentheses, that's going to be distributive property. Okay, like I said, there's going to be certain things that we're going to start seeing that we can start relating together. Just like when we go to, when we see that instead of an angle is equal to an angle, we know that that's a definition, okay? All right, and once we have it as the distributive property, it goes off and shows that the measure of angle 1 is 90 degrees because of the division property of equality, which goes to angle 1 is a right angle from the division, from the definition of a right angle, and eventually we get to the definition of perpendicular lines where G is perpendicular to H. Like I said, to me, this is a whole lot more confusing, okay? my goal, like I said, the reason I'm even doing the 2-column proofs is just to kind of help us see how the things relate. I don't want to confuse us with the organization. I don't want you to focus more on organization versus content. So like I said, I just wanted you to see it. We're not going to be using this. Easton?
If like on a test, like on ACT, if they ask for the flow proof, we have to
There is no flow proof on ACT. There is none, because all of ACT is multiple choice, and proofs are not on the ACT. So don't stress about that. Alrighty. So, and one of the things I will be doing, I do have a document that I printed up for this summer when I was teaching geometry, and I have a full document of all geometry that is on the ACT, so you can see exactly what things you need to remember from geometry when you're taking the ACT. All right, so it just talks about the types of proofs. Now we've studied 3 types of proofs, and we found that we do not like 2, and we'll stick with 1. So basically, that's all this section was about, okay? So what we're gonna do is, let's look at the guided practice. So it says, perpendicular lines. What's our definition of perpendicular lines? 2 lines that
are equal to each other,
no,
or
perpendicular.
are the exact same apart.
So no, that's parallel.
Parallel.
Perpendicular. 2 lines that do what? No, perpendicular do intersect. Parallel do not. Parallel lines are my railroad tracks. Perpendicular is like an upside down T. That's our symbol. So if we think about perpendicular and we use, where's our little symbol? Okay, remember this symbol right here means perpendicular. So if I remember the symbol and I remember it's like an upside down T, I can see that this line intersects with this line. So my definition of a perpendicular line is going to be 2 lines that intersect. And what does it form? 4 what?
Right angles.
Right angles. Okay. So you can picture a cross. You can picture the upside down T. Clear?
I like to do like a parallel since it's got 2 L's in it. They're parallel to each other.
I like that. So think of, that's a great way to remember that. Thank you for sharing that. So parallel has 2 L's. That's our symbol for parallel lines. Okay, so that helps you. Thank you. Never thought about that. But I love little tricks like that. Okay, so the first one, perpendicular lines, 2 lines that intersect to form 4 90-degree angles. Which postulate or theorem guarantees that there is only one line that can be constructed perpendicular to a given line from a given point not on the line? So which definition or which postulate or theorem did we see that told us that?
The definition of congruent.
No. Well, it actually says what postulate or theorem, so it's going to be a postulate or theorem. So which one did we learn in this section? Now it says about that it can be that only one line can be constructed perpendicular to a given line from a point not on the line. Actually, I guess it is back in the last section. Turn to 130. Which one tells?
Perpendicular postulate.
Perpendicular postulate. There is only one line that can be constructed perpendicular to a given line from a given point not on the line. That is our perpendicular postulate. Okay. All right, so let's look at 3. It says write the postulate or theorem that justifies the statement about the diagram. So this is not all in this section. Let's look at number 3. Angle 1 is congruent to angle 2. What is the relationship between these 2 angles? I'm sorry? They're vertical angles. Remember, one of the things you can remember is if I have a V here and a V here, these are vertical angles. They are 2 V's that meet, okay? Vertical angle. So our vertical angle postulate tells us that. Number 4, J is perpendicular to K. What postulate tells us that, what do we have about these two angles here?
Theorem 1.3.
So notice that it's telling us these two, when I have, remember when I have these little arc things here, and notice that there's just one for each of them, that tells me that they are equal to each other, okay? And so that tells me that they are congruent. So theorem 3.1, okay, flip back. It's going to be on page.
Page 137.
137, 3.1. If two intersecting lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Notice that they highlighted here congruent angles, so we know that's the theorem we're looking at there. Postulate or theorem that justifies the statement given that G is perpendicular to H. Okay, so in each of these, so number 5, they've already told us that G is perpendicular to H, but notice I've got the measure of 5 and the measure of 6 equal 90 degrees. Theorem 3.2, look back at 3.2 on page 137. You can see that if we have two angles that have an adjacent side, they equal 90 degrees because they're complementary. Look at number 6. Angle 3 and angle 4 are right angles. Which theorem does that come from? 3.3. If two lines are perpendicular, then they intersect to form 4 right angles. All right, let's look at number 7. It says find the value of X. What do I notice about this angle here? Its measure is going to be 90 degrees because these are vertical angles, and they've told me that this is 90 degrees. Okay. Number 8. What do I know about these two measures here? Huh? Complementary, so that means they're going to add up to equal 90 degrees. One of them is 45 degrees, so what is the measure of X? 45 degrees, yeah, subtract 90 minus 45. We know 45 times 2 is 90. So 45 degrees on number 8. Number 9. 90 degrees, okay. This one is 70 degrees. What is the measure of X? 20 degrees, fantastic. All right, and finally number 10, we have an error analysis. There's an error here and we got to figure out why. It says it is given that angle ABC is congruent to CBD. A student concludes that because angle ABC and angle CBD are congruent adjacent angles, so think about this, congruent adjacent angles, then AB is perpendicular to CB. What is wrong with this reasoning? So think about this for a minute. It says to draw a diagram to support your answer, so we'll talk about that just a minute. But what is the thing? So here it says that we have angle ABC is congruent to angle CBD. So they are making the conclusion that because they're congruent, that they are perpendicular. So let's think about this for a minute.
Congruent means equal to, and perpendicular means opposite. So they can be both at the same time.
Well, congruent means that they're the same. So
The perpendicular basically means they're opposite. Kind of.
if this was, let's say 35 degrees. No, it's gotta be more than that. Let's say this is 60 degrees And this is 60 degrees. Are these congruent angles? Those are congruent angles because they're, so are my lines perpendicular to each other? Because if I had, and actually let me fix that real quick. Let's do this. I need to erase this one because I didn't. Okay. All right. So take a look here. These are congruent angles. So if I had, oh, I didn't, that doesn't work either. Basically, we could just use this. I could actually just name this one here. So basically, looking at this, just because A, B, C, and C, B, D are congruent, it does not mean they're perpendicular, because perpendicular
All this, the website.
Yes. Are you there, Keely?
Yes, ma'am,
Okay.
I'm here.
So, sorry we're having so many problems. It's almost time for class to be over. So what I did is I just went ahead and assigned the homework for these pages. It's going to be on page 139,
Okay.
numbers 12, 14, and 16.
Sorry, say it one more time. The numbers again.
So I can tell Keely real quick. Page 139, numbers 12, 14, and 16. And then page 140, number 19. So that is it for this section. And then the test. Okay?
Okay.
And I emailed your test to you. Please let me know if you don't get it. If you
Yes,
haven't gotten it,
ma'am.
okay?
Yes,
Alrighty,
ma'am,
we'll
thank you.
Sorry about the problems today. Hopefully
No, it's no problem. It's fine.
next week. But if you have any questions, be sure to let me know.
Yes, ma'am, I will. Thank you.
Okay. Bye. Have a great weekend.
You too. Bye.
Bye-bye.
It's good.